don't get to talk about finance much. It tends to be a very secretive environment in the financial markets talking about data science. I started building software predicting stocks markets and individual stocks in high school at Princeton. I built my first gradient descent using Wolfram Mathematica to optimize portfolios of global stock markets, continued developing models for stocks, bonds, and commodities at JP Morgan, starting in 1997, joined a hedge fund in 2002, became a portfolio manager for that hedge fund in 2006, and founded V2 Ratings in 2014. I recognize some of you from New England AI, a meetup that I started in 2011 after the Stanford online data science classes, Intro to Artificial Intelligence and Machine Learning. I also like helping startups. I've touched on adaptive learning and recommendation engines, ad targeting, healthcare AI, and other domains. The tools for this type of work have become almost magically good, very powerful. We've reached an inflection point, I think, where processing speed and networking, the availability of inputs through APIs, have enabled new levels of intelligence. It's a very exciting time. There's a lot of ways that data is changing the investment industry. The two major categories are passive and active investing. Passive investing tends to use funds and target a strategic allocation that's designed to manage risk for the investor. This is an important innovation, being able to automatically manage and maintain a portfolio. For example, rebalancing weekly or according to some triggers. Active investing involves more trading. It might include funds or other securities, individual small securities options and structured products. I'm going to focus on active management, specifically algorithmic trading and decision support. I'll cover a little bit of the history and speculate a little bit about the future. Algorithmic trading is when you build computer models to send buy and sell orders or signals to a human. I'm not talking about high-frequency trading. This is about trying to predict price and take a position based on that prediction. It's not about exploiting market structure or getting in advance of somebody else's trade. It's about forecasting. Decision support is like algorithmic trading, except that it produces signals rather than trade orders. These signals might indicate trades, but they might also indicate directions for earnings, warning for risk, or anything else. Ratings agencies are essentially decision support companies. They provide credit ratings to indicate risk. You can see there's a couple companies here that I listed. These are some of the world's largest algorithmic trading or decision support companies. They use algorithms and humans to manage hundreds of billions of dollars, and their management fees every year cumulatively for those companies and other companies who do this are probably in excess of $50 billion per year. And that's just the management fees. If they have good performance, those numbers can go up from there. It's extremely profitable. They tend to be very secretive, and for good reason. When I started, most analysis was forecasts based on traditional statistics, correlations, standard deviations, conditional probabilities, time series analysis of prices. Until 2004, we had models that were based solely on price. We used rolling window of normalized price movements to predict changes in price. Looking back now, it's pretty elementary feed-forward neural network. It was a fully connected network with a single hidden layer, and it performed okay for a couple of years. Now, looking at this, it reminds me of Word2Vec. I don't know if any of you guys know that, but if you're into natural language processing, that's a very cool technology. You should look into it. Different models have different lifespans. They disappear when the arbitrage is discovered by too many market participants. Usually you don't see it coming. A model just slowly dies as other investors start to exploit the same dislocations. It's a race. Everybody tries to keep ahead of everybody else. One time we did see it coming. A professor at Yale published a paper, and within 3 weeks, the excess return from that model just disappeared completely. It's fun to see how quickly information can spread in this environment, and it's sad when a business model disappears in 3 weeks. But about that same time, we were experimenting with adding simple fundamentals. Value line would send us a physical CD with a CSV file on it with fundamental data from SEC filings for a couple thousand stocks, and we would parse that CSV and include some of that data in our models. We began integrating information like revenue and earnings growth, and this was important. I'll come back to that. The financial crisis in 2008 and 9 was a turning point for me. It's partly why I can give this talk and tell you about what I'm working on. I watched as the ratings agencies gave safe ratings to crazy structures of bundled mortgage-backed payments. The pristine ratings drove billions of dollars from pension funds and other institutional investors into mortgage-backed securities. Investor demand drove mortgage originators to issue more mortgages, and the cycle of cheap money and bad loans and blind ratings contributed to a crash that cost investors their retirements and cost borrowers their homes and had knock-on effects that spread into other countries and asset classes. So I was upset. The ratings agencies have thousands of employees, terrible conflicts of interest, deep biases, inconsistent processes, slow update cycles, lack of transparency. Any investor who wanted to analyze a history of credit ratings against current prices would have a challenge ahead of them trying to collect enough data to be able to assess whether the credit ratings agencies were ahead of the market or simply following it. I couldn't see the value to investors. There's a legitimate purpose for credit ratings agencies. They get special legal treatment for the role that they play, and many federal and state pensions are actually required to invest based in part on these ratings. Most large pension funds have mandates voluntarily that also cause them to invest according to the ratings agencies. When the ratings are bad, then not only do investors lose, but capital gets deployed inefficiently on a global scale. And that inefficient allocation of capital means that companies that really need it are starved of capital and global growth slows. The Justice Department sued S&P, got a $1 billion settlement, but I come at this from a technology and data perspective, and we can use now market pressure to force change. We can automate consistent processes, fast and deep analysis, transparency, so we can burn the old system to the ground. We're now publishing investment ratings as a SaaS model, providing stock ratings to the public and to institutions. Our investment ratings are not credit ratings, but that's the direction that we're going. Let's talk about fundamentals and investment philosophy. This will inform our system design, and it'll be directly reflected in our data pipeline. Having a sound investment philosophy gives you the best chance that your models will tell you something useful, and it's the first line of defense against catastrophic market model failure. For example, don't bet on momentum or other reinforcement loops. These tend to push markets until they pop, either up or down, and taken in the aggregate can cause larger systemic problems. There's 1,000 small ways that errors can creep into your system. Even big companies who are very good at this can blow themselves up with logically flawed models, inappropriate investment philosophies, careless errors, or other minutia. So be careful. If you want to read a particularly dramatic tale of an algorithmic trading model that blew up, look for the night trading disaster on Google. It's pretty fun. For our purposes, we're going to select an investment philosophy that gives us long-term models for long-term capital gains and minimal daily trading. Our starting place can be summarized by this old adage by Benjamin Graham. In the short run, the market is a voting machine, but in the long run, it's a weighing machine. And that is a beautifully concise way of saying that popularity and bias drive short-term market activity, but in the long run, prices come back to their fundamental value. Peter Lynch talked about it more concretely. He said, often there's no correlation between the success of a company's operations and the success of the stock over a few months or even a few years, but in the long run, there's a 100% correlation between the success of a company and the success of its stock. This disparity is the key to making money. It pays to be patient, to own successful companies. So we're going to build on that philosophy. We're trying to determine fundamental value and deviations from it. We'll aim to capture alpha from reversion to fundamental value and let chaos and market biases work in our favor. So it's not reversion to the mean, it's reversion to fundamentals. Overall, the pipeline consists of generally 3 stages. Collecting data, cleaning it up with pre-processing routines and validation, normalization, and also tagging it with descriptive terms that we're going to use later. Pre-processing is where we encode some domain knowledge and we create prepackaged features that we think will capture some information that may be helpful for the models. The second stage is creating these populations of models to assess value and risk, and then finally integrating those models with post-processing to produce a useful signal for other machines or for a human. So we'll skip most of those stages and just focus on the one hypothetical risk model. That's sort of where the meat of all of this is. After pre-processing, there's tens of thousands of potential inputs. We need a way to search that space. There's nonlinear dynamics, so we're going to want hidden layers. We have a couple of thousand stocks, several years of quarterly SEC filings and daily price data. So those are constraints. We need to work within that amount of data. We can't have a large, fully connected, deep network. We just don't have enough data for it. And those of you who are familiar with convolutional neural nets may see an opportunity here. There's some parallels to image classification. And if you are familiar with convolutional neural nets, you know that those have had tremendous progress just in the last year, couple years in image classification. Jan LeCun, the inventor of convolutional neural networks, is now at Director of AI Research at Facebook. He did a great talk on convolutional neural networks at the Hot Chips conference. It's available on YouTube. I highly recommend it if you're interested. Models like CNNs allow us to build much deeper networks at the same cost and train on smaller data sets than fully connected networks. They use less memory because of shared weights. They have generally include pooling, which is a lot like what human investors do, so it has some parallels to the way that our brains handle this kind of information. They have a lot of advantages for our use case. Because of their depth, they don't require as much pre-processing. They're able to discover more and more complicated features from the data than any human would encode. I'm not saying that financial forecasting is easier or harder than image classification, but the data is smaller and we're predicting fewer things. Image classification may aim to classify thousands or possibly tens of thousands of categories. We have just a couple dozen, probably, different measurements for risk, different types of risk, different time frames for risk, different ways of measuring value. So that also simplifies the network. And the parallel here, I'm going to flip back and forth between these two screens, you can see. What we're going to do is instead of using convolutional neural networks with geometrically based hidden layer architecture, we're going to have our hidden layer architecture based on the accounting structure. This is why we tagged our input data. Rather than traversing the inputs geometrically, we're going to build our hidden layer architecture based on the fundamentals. Finally, after the data goes through this process, we have predictions for value in several ways, for risk in several ways. The combination of value and risk is what the ratings are based on. We're scoring individual companies and normalizing the data so that it's digestible for a human. The models that we produce give you a partial picture. Like anything that comes out of data science, our ratings, for example, don't analyze the strength of a company's technology or intangibles, social media or brand or macroeconomic demand trends. In our results, you can see some great companies are rated low because widespread optimism is justified. There are legitimate reasons to think some of these companies deserve to look overpriced on their financials alone. The market's confidence may be well-deserved, and vice versa. So human judgment can be helpful as you consider intangibles that affect companies before making investment decisions. So that's why tools like ours are considered decision support and not pure trading signals. Some people do execute fully automated trading algorithms, particularly when trade timing is very small, very fast. I recommend against these unless you're really confident in what you're doing. We slapped a UI on it. V2 Ratings has a free version. The ratings are daily and delayed, but totally sufficient for most investors. We make our entire history available for each stock. You can download the complete archive for your own analysis, backtesting, and monitoring. We do continually work on the models, so you may see big changes. One such change took place about a year ago. You can see there. One of the problems with transparency is that all your old models are there for everybody to look at. And you can see at that point, we added a bunch of new inputs. We actually added a whole new layer of pre-processing that checked a new category, a new class of inputs. And the reason that we did it was a lot of good companies were being punished for poor fundamentals when we were just looking at them too narrowly. So when we considered a broader set of input data, companies like this one went from being rated approximately 0 to being rated as high as we go, close to 10. So that's the downside of transparency. It's probably why a lot of companies don't do it. Some of what we do isn't really machine learning. It's about communication. Part of what we show is interesting tidbits that are extracted from our analysis. We use simple rules to write simple sentences. And while the sentences are simple, they do help shine some light into the black box, revealing some of the factors that influence a company's rating. They also give analysts a quick heads up right after earnings reports are released so that surprises and outliers are easier to identify and analysts can make better decisions. For institutions or data scientists, we offer an API. It's also free, so feel free to play with it. And I wanted to introduce one such user, an industry partner, who I think is using our data in a great way. Kai Trepta is the founder of OBB Solutions, a data-driven consulting company that specializes in supply chain and process controls for large public, industrial, consumer goods companies. He'll take a few minutes, and then I'll have some final words about development and the future, and take some questions if there's time.
Great. Well, so the question is that companies in many ways are black boxes, as are their supply chains. You have inputs that are known, what people are selling. You have outputs, such as inventory and all of those sorts of things, but people don't understand what's happening inside of those processes. And so what I've made my career on is helping people do that. The issue is that there's a big translational problem in the sense that people in the C-suite talk in terms of EVA, ROE, ROA, and people who are actually on the ground talk about stock picking location 351 and product ABC getting shipped to customer X. And there's a huge gap between those two things. And what V2 lets us do is it lets us give internal people an external activist investor view. So we can show them what are people looking at within your company. So when you're going to take an action, you can see the impact of that action on your external metrics. So very simple things to do with the API, for example. You can get a list of all of the little messages that Dan showed you, and you can see where a particular company stacks up. And so for us, we start to get people to understand where do you sit relative to your peers, relative to your peer group, relative to companies you aspire to be like. So that you can see, okay, I am an old line manufacturing company. I am not going to have the same return on assets as a Google, for example. It's just not possible, right? And so this lets us start to help people formulate the kinds of strategies that external people are going to use to, for example, invest in them, to try and take them over, to take a minority position and force change, so that they can now start to take internal action, in essence, to protect their jobs. And so this is what people who are running companies care about. Well, what do people who are doing the work care about? They hear, well, we have this strategy, we want to decrease inventory. Great, that's fantastic. So for example, here we look at a company, for example, Tyco, and you see they've got the lowest inventory to sales numbers, right? You also notice they have the lowest sales growth. You notice, for example, that their accounts receivable, right, are in line with everybody else, but their inventory as a percent of assets are also low, but their accounts receivable as a percent of assets are in line with everybody else. Well, what does this do? This starts to make the translation between strategy and financial decisions and supply chain, boots on the ground, what's actually going to make the company perform. And so without V2 ratings, you can't really do this because there's no robot that's going to go screen through all this stuff and put it in an API that you can go and look at and use regularly. Well, with this information, for example, I can go to a company and I can say, look, your inventory is too low. What does that mean? Well, it means that you're underperforming from sales. So what would happen, for example, if you increase your inventory, right? From a strategy perspective, people who are at higher levels are going to be like, oh my God, this is going to be terrible, right? Because they look at it and they say, oh my God, this is going to kill my balance sheet, right? All my assets are going to go up, my ROA, my ROE are going to go down. Well, not necessarily, because all of these metrics, right, are intertwined. And this is basically the black box that we open up. It's giving people the ability to really understand all of the interconnections, to say, yes, you can raise inventory and you will get better results. And we do that through a combination of using the V2 information and then coupling it with internal company data that looks at how are their customers broken out? How are their products broken out? How is their inventory broken out? What's predictable? What's not predictable? So we can say, for example, take these, right? You have a lot of value, low predictability. If you think about earnings numbers, well, those products and customers are people that you need to pay attention to if you're going to make your quarterly earnings numbers, right? Because in all likelihood, actually, when we did this analysis, they were about 6% of total revenue, right? That is enough to actually move the needle. And so by having the V2 data, by having the internal data, and then by blending the two in a model, we're able to give people real guidance about what should they focus on, what should they pay attention to, and how can they get better and more consistent financial outcomes. And that is a pretty exciting place to be. And when you think about it, it's only with robots and only with APIs that you can even start to do that. Because traditionally, people would hire a consulting firm. They'd spend 3 months doing the analysis. They'd charge $1 million for it. They'd give the results. Everybody'd say, this is great. They'd go do a bunch of stuff. And then they would never be able to get the feedback because they'd have to spend another 3 months, another $1 million. And it's just a cycle that's not sustainable. Using tools like V2 and coupling it with our supply chain expertise, you can really start to make that happen on a regular basis so people can actually see and watch improvement take place. So that's what I wanted to share. So hopefully you found that interesting. We find a lot of value in what Dan's doing, so hopefully you will as well.
Thanks, Kai. The API that you're using includes 50 accounting notes from SEC filings. It comes out, it takes about 10 minutes to produce after the SEC filing, and it could include tens of thousands of notes on these filings, but what it does is it narrows it down to the top 50 based on what is rare in the market. So the kinds of information that it's talking about are the things that don't show up in other companies. It gives you sort of a list of things to pay attention to, important notes about changes that are out of line with the rest of the market, or statistics that are rare in your industry. So it can be helpful in a lot of different ways. I'm so glad that you found a good way to use it. Let's talk a little bit about the future now. We're planning. This is all speculative, but the combination of convolutional neural networks and recurrent neural networks, I think, will be very powerful. Right now, what we're doing does not include the time series analysis that is a natural outcome of the recurrent neural networks. When you take components of the hidden layer and put it back into the model as an input, it gives you the ability to have a cyclic graph as opposed to a purely acyclic graph, and that lets time begin to play a role. So it takes the hidden layer, includes it back in as an input, and that provides a context from the previous period. So if you haven't already read it, Karpathy, his blog post on the unreasonable effectiveness of recurrent neural networks is a really good read. Another thing that we're hoping to add is the portfolio effect. This is more complicated than you might imagine. When you're combining stochastic assets, they're not all perfectly correlated, and so you need in order to calculate the risk of the combined portfolio, you need the correlation matrix of all of the individual securities. So as your portfolio starts to increase in size, as you want to find the efficient frontier for the entire market, the calculation gets incredibly large. There's also problems, because you might look at two securities, think you know the correlation between them, but then there's another dynamic that occurs when volatility spikes, your correlations spike too, and you are only as protected as you are when the correlations have spiked. So there are a lot of confounding issues in that. We think we have some tricks. I've spent a long time working on those tricks, so I think that will probably come in the future. All of this is working toward the integration of logical pipelines, live monitoring of news feeds for elevated stress levels. This is already happening. Newscaster voices, facial expressions, heart rate text being parsed for keywords and meaning, weighting the significance of tweets based on the historical performance of the person who's sending the tweets, implication analysis that spans across markets, and continuous monitoring, response to all the world's data. If there are any questions, I'd be happy to try to answer. Yes? Hi, Joe. Well, sure. Yeah. I mean, I closed the hedge fund in 2012, opened this company in 2014. But the hedge fund was profitable, had alpha. Yeah. Thanks. Sir? Yes. Commodities work a lot like fixed income. They trade on, if you're trading futures at least, they have a futures curve where depending on the date of the expiration of the futures contract in the future, you can form what looks like a yield curve. So a lot of the same math that applies to the fixed income markets apply to the futures markets for commodities. And so it works just as well. Yes? Yeah, we have a divided architecture. We keep all of our proprietary models in proprietary I don't really want to talk about that part. But once the data is processed and the ratings for every stock are produced, we push it up through a bastion host, which communicates with Amazon AWS for fan-out. So that way, if our infrastructure is somehow accessed inappropriately, they might get some user accounts, they might get the ratings data, but they won't get the models. And trying to track it back, they'll run into the bastion host and reach a dead end. But we're mostly a Python house. You know, Python has good wrappers around, so we can still maintain speed. With CUDA, we've experimented with that. It's not in our production pipeline, but yeah, we are using it for some things. Yeah, a lot of experiments with it, but we haven't moved it into production. Seamus. Yeah, we use a lot of open source. Our own code stack is a tiny fraction of the total amount of code. Yeah, there's open source throughout. Any particular Postgres and we actually rolled our own modeling, which is why we've been experimenting with Theano. It's not as fast as it would be if we used some of these libraries that have already been optimized by many more people smarter than us. Anyone else? It is. Data acquisition is the most expensive part. Yeah. We use FactSet for fundamentals, and it's pretty great. We've experimented with a lot of different sources. For a while, we were getting duplicate sourcing on our inputs, and then we'd, prior to pre-processing, run everything through a belief layer, which we called it a belief layer to try to assess whether we actually believe that the data is true, testing data against each other and also testing it for rationality. But now that we're using FactSet, and so we've actually cut that layer out. It's reliable, but it's expensive. Sure. Yeah, not as much. They're mostly in a panic. Companies like Two Sigma and Renaissance, they're eating their lunches, and the kinds of expertise that are helpful for building these kinds of systems are not the same. So it is helpful to have both a good economic understanding and a good technical understanding. But a good technical understanding is hard to attain, just like it would be hard for a data scientist to come and become an economist. So there's a bit of a crisis there. I think companies like Bridgewater, they are the world's largest hedge fund, and they started out as a fixed income newsletter and grew as an asset management company. They have had a huge push to hire AI, data science, computer scientists, engineers, to build this kind of thing, and I suspect they'll be quite successful. But I think Two Sigma is something like 700 employees, and maybe similar for Renaissance.
Have a distributed or cluster computing?
Yeah, again, we rolled our own with that, but we've been experimenting with Dask and Castra, which are relatively new and I think great for distributing the data and the processing. So I would look into those if I were starting from scratch today. Yes? Yeah. There's a ton of them. We are looking at a very narrow spectrum of input data. We're looking exclusively at fundamental data and price. So we can do analysis cross-sectionally across different companies, different industries. But all of that cross-sectional analysis is based on those fundamental data. And so we miss things like the skill of management, the value of the technology, we do build in some of it because we get an assessment for the percentage of a company's revenues that are going back into R&D. So there's some indicators in there, but we don't really have a good way of capturing a patent portfolio. We don't have a good way of capturing industry trends. We probably would have thought that Kodak was a great company all the way down. Lately, oil companies have been rated very highly because their fundamentals look great, but there's a lot of other confounding factors that are just not built into the system. So it'd be nice to build all of that in. Maybe have somebody look at the patent portfolio of every company, give it a score, an assessment, and use that as a feature on the inputs. But that's not happening now. And if it slowed us down, if it's our update cycle is about every 10 minutes right now, and that's an important feature for our customers. Yeah, it just takes a while. This is why we've been exploring more open source tooling for some of the processing. It is a little bit slow, but 10 minutes is fast enough, and our the companies that we go up against are updating daily or weekly, or credit ratings agencies. They update right after the horse left the barn, so we have an advantage. Thank you all. Thank you all. If you have any questions, feel free to send me an email or contact me.